Hello, I'm Mr. Bob, and welcome to my Geometry Review video series. This video covers Chapter 11, Section 5, titled Circles in the Coordinate Plane. By the end of this video, you will have reviewed recent lessons describing procedures for writing an equation of a circle and using the circle and a point on the circle. Next, you will review finding the center and radius of a circle by graphing a circle if given its equation. You will end by reviewing a real-world problem. If you need me to cover any of these topics in greater detail, please leave a request in the comment section below. Please subscribe to this channel if you find this video to be helpful. Thank you. Okay, so to get started, let's look at a definition. Standard form, the equation, the quantity x minus h squared plus the quantity y minus k squared is equal to r squared. This is the standard form. You may also call it the standard equation of a circle. Okay, objective 1, writing an equation of a circle. It says here you can use the distance formula, if you remember that from the past, to find an equation of a circle with center h, k and a radius of r. So let x and y be any point on the circle. Any point on the circle. Then the radius, r, is the distance from hk to xy. That would give you your radius. So the equation r is equal to the square root of x minus h squared plus the quantity y minus k squared. And that's your distance formula, remember it? Or we can square both sides and we can get r squared is equal to the quantity x minus k squared plus the quantity y minus k, x minus h squared, plus y minus k squared. That's the formula that we're looking for here, which is the equation of a circle. This essentially proves the following theorem. An equation of a circle with a center h, k and a radius r is the quantity x minus h squared plus y minus k squared equals r squared. So the equation r squared equals the quantity x minus h squared plus the quantity y minus k squared is in standard form. That is the standard form. You may also call it the standard equation of a circle. It pays to memorize both of those. Okay, example 1, writing the equation of a circle. Write the standard equation of a circle with center at 5, negative 2 and the radius of 7. Well, in order to start that, we're going to go ahead and we're going to write the equation itself to begin with. And the equation is, as we looked at it on the previous slide, right here, the quantity x minus h squared plus the quantity y minus k squared is equal to r squared, the radius squared. So our h value is the x, so it's the y term. So as you see it here in the second equation, we replace the h with 5, which is the x term, and the k term we replace with a negative 2. But you see we put it in parentheses because it's minus a negative 2. So we have to make sure that we carry the negative 2. Okay, and then we substitute it in the 7 for the radius. And when you solve that, you look to write the equation. That's all they want us to do is write the equation. So now we have x minus 5 squared plus the quantity y plus 2. That's where our two negatives came in. The plus 2 squared is equal to 49. And that is the standard equation. Okay, example 1, check your understanding. So it says write the standard equation for the circle, given what we have for two problems here. Okay, we'll go ahead and stop the video and you should try these on your own. And then when you come back, we'll do them together. Okay, assuming that you stopped the video and did the work, let's go with the problem A, right? Well, I have it surprisingly on another slide. So we have information here that's now the standard form of the equation in both cases. Okay, and then we filled in the missing info. And the missing info in the problem A is x is 3 and 5 is the y term, right? So, and the radius is 6. So on the second equation, as you know, I said the first equation is the standard form of the equation. We're going to write the x minus h, and it's a 3 is what's going to, the 3 is the value, the x term is we put in because we're dealing with x's. So it's x minus 3 squared plus the quantity y minus k, and k is the y term right here, 5. K, so it's y minus 5 squared equals 6 squared. And then when we finish this and complete it, it's x minus 3 squared plus the quantity 5 minus y minus 5 squared is equal to 36. The second problem, we have x and y both with negative values and a radius of the square root of 2. Okay, so writing the standard form of the equation, it always helps to write these equations. The more often you write them, the easier they'll be to memorize, right? You'll write them and write them and write them. Pretty soon you say, I know the formula. So now we're going to replace our x and y term in the standard form. And when the term is negative, remember you put parentheses around it. Add the entire term. The negative goes with it. So it's the quantity x minus the quantity negative 2 squared. And then y minus the quantity negative 1 squared is equal to the square root of 2 squared. So then when we complete the math, we're going to get the quantity x plus 2 squared plus y plus 1 squared, because negative 1 and negative is a positive, right? The negatives are positive. And that equals 2. The square root of 2 squared is 2. Okay, good job. Okay, example 2, using the center and a point on a circle. Find the center and the radius of a circle with the center at 1 and minus 3, x equals 1, or I should say h equals 1 and minus 3 is equal to k. H and k is the center. Remember that h and k term is the center of your circle. The x and y terms are the point on the circle. And it passes through the point 2, 2. That means that 2, 2 is on the circle. You can see it in the diagram here, that 1 minus 3 is the center of the circle. We go over here, we go in positive 1, negative 3 to get to the center of the circle. And 2, 2 is on the circle. So once we fill those in, we're going to complete this problem. You'll see it. So writing the distance formula, and remember that it's the same as our standard form equation, except the square root. It's not x squared. We've taken the square root of everything, right? So r, the radius, is equal to x minus h squared plus y minus k squared. Okay, so when we substitute in, which we're going to rewrite it as r, the radius, is equal to the quantity 2. 2 is the point, the x point on the circle. The x and y is on the circle. Minus 1, the h value, which is 1. Okay, so it's 2 minus 1 squared plus the y value, which is the other 2 over here in the y value, and the point on the circle, the x and y values, and it's passing, or it's the k value is the negative 3. So we've got the negative 3, the quantity, negative 3 squared. So now we've solved this. What do we have? R equals the square root of 1 plus 25, because 2 minus 1 is 1 squared is 1, and 2 minus a minus 3 is a 6, is a 5, and 5 squared is 25. So the square root of 1 plus 25 is equal to the square root of 26, right here. Now that we have that, we can go to the standard form. Almost going to repeat everything we just did. It's x minus h squared plus y minus k squared is equal to r squared. And then what we're going to see here is now we're going to leave the x and y value in. So we're writing x minus 1. That's our 1, right? Same right here, the 1 from before. Squared, and y minus a negative 3. Here's our negative 3. Again, up here. Squared is equal to 26 squared. So now we simplify, which is, we're going to just write x minus 1 squared plus y plus 3, which is minus a minus 3, right? Plus 3 squared is equal to the square root of 26 squared is 26. Okay, I think that worked out pretty good. Okay, example 2, check your understanding. They'd like you to do this one on your own, so you know how to do that. Just stop the video and work it out, and then we'll come back and we do it together. But it says, write the standard equation of the circle with the center at 2, 3 that passes through the point -1, 1. Start by finding the radius of the circle. Use the distance formula. Little hint here I gave you. Okay, I'll wait for you. Okay, now that you're back and we're going to move forward and take a look at this together. It's the same equation and problem we just worked on, but now just the numbers are a little different. So first thing we do is we're going to write the standard the formula for the distance formula, right? So the one we've used a number of times in the past. That's right here. R is equal to the square root of the quantity x minus h squared plus the quantity y minus k squared. Substituting our values, and now we have a center point, which is 2, 3, and a point on the circle, which is -1, 1. Okay, so now we're going to fill it in. We're going to have the x value is the -1 over here. X is -1, and the y value is -2 or -2 because it's a 2. So we just subtract that value, and then we square it. And then we have 1 minus 3. The 1 comes from the y value on the circle, and the -3 comes from the center, the y value for the center, and that's squared. And then once we do the simplification, we get the square root of 9 plus 4, which is the square root of 13. That's our answer for the radius. So now we take our same numbers and plunk them into the standard form for the circle, which is x minus h squared plus y minus k squared equals r squared. Okay, so x, we just put in x because we're not using the circle point anymore. We're just using the center and the radius. So x minus 2, our standard 2 up here, squared, plus y minus 3. Here's the 2 and the 3 right here, up here at the top, 2 and the 3, and squared, and that equals the square root of 13 squared. So then we're going to simplify. It's x minus 2 squared plus y minus 3 squared is equal to 13 because the square root of 13 squared is 13. Good job. Okay, objective 2, finding the center and radius of a circle. If you know the standard equation of the circle, you can describe the circle naming its center and its radius. Then you can use this information to graph the circle. So example 3, graphing a circle given its equation. So find the center and radius of the circle with the equation, the quantity x minus 7 squared plus the quantity y plus 2 squared is equal to 64. Then graph the circle. So writing down the equation as it states in the problem, which is right here, we've repeated it right here. We've noticed right off the bat that 64 should be r squared, right? If you take the standard form, r squared is what we're going to return this to. It's going to return it. We want the r value. So we're going to substitute, or we're going to look at these values. The h value is the -7 right here. The k is the -2. Okay. And 8 is the radius, the square root of 64. The center is the h is the x term, the k is the y term, and we know the radius. So the center is 7, -2 with a radius of 8. And then to graph the circle, you place your compass point at the center, 7, -2, which they've done right here. If you look at it on the screen here, 2, 4, 6, 7-ish, right in about here, right? And 2 down, -2 down right here. Right in the middle, right in there. I should have been using a different color. Let's try if we can use red. Right here. Yep. Put the point of your compass right there, and then you scribe off a 8-unit radius circle. Well, how do you get to, what's the best way to do that? Well, if you have a graph that's pretty accurate, you can lay your compass point from your point, say at 0, and you can stretch it out 8. And then that's your measure. You can measure easily relative to your graph. And once you have the measure relative to your graph, then take your point and put it where the center is, and then draw the circle, and you'll have your radius of the circle. So what you do, graph it, place the compass point on the center, and then draw the circle with a radius of 8. Okay, example 3, check your understanding. It says find the center and the radius of a circle with the equation x minus 2 squared plus y minus 3 squared equals 100, and then graph the circle. So I'll let you take some time and go off on your own and try it out, and when you come back, we'll try to go through it. Okay, now that you're back, let's go ahead and try this ourselves here. So we have find the center and radius of a circle with given that it's x minus 2 squared plus y minus 3 squared equals 100. Then graph the circle. So I have the equation written down here, right here, just rewrote the equation. And determine from there, where is the center? Well, the center is x of 2, y of a 3, and r of the square root of 100, which is 10. Okay, so the center is at 2, 3 with a radius of 10. So over here I have a piece of graph paper-ish, a picture, but it isn't, the increment isn't enough to cover 10 or more, or whatever. So I'm saying that the graph increment is times 2. So if it says 1 on the graph, it means 2, right? So we'll play that game. And what I did is I drew a dot at at x equal 2, which here's the 1, which means it's 2. I went out 2 and up 2 to 3. This dot is supposed to be at 3, is where it's supposed to be, right here. I missed a little bit. Anyway, so it's 2, 3, and the radius is 10. So the radius is 10 from we'll pick a spot right here from on the line of 2. We have to go out to 6, which is 12, right? So that's how I measured it out. I got the circle out here, and we drew it around. So this is a radius of 10 circle with the center at x equal 2, y equal 3. Okay, example 4, it's a real-world problem. Communications. When you make a call on a cell phone, the tower receives the call. In the diagram, the centers of the circles O and A are locations of cell towers. A says, the equation x minus 16 squared plus y minus 10 squared equals 100 models the position of tower and range of tower A. Describe the position and range of tower A. Well, the equation is x minus 16 squared plus y minus 10 squared is equal to 10 squared in standard form. It shows that the tower A is located at x equals 16, y equals 10, and has a range of 10 units. Now, a new tower is to be built at B with a range indicated in the graph. Well, you see the red tower, and it's the range in the graph. Write the equation that describes the position and range of that tower. So we're going to do basically the same thing we've done in the A tower. And this one says that the center is 4, 20, x equal 4, y equal 20, and a radius of 10. So substitute these into the equation. So the equation is down here. The standard form equation is, there it is. The standard form is written here. And then we're going to fill it in with our numbers. So it's x minus 4, the x value, and it's squared plus y minus 20, the y value. Right here, the 20 is the y value, squared, equals 10 squared, or 100. Okay, so the standard equation we're writing is x minus 4 squared plus y minus 20 squared equals 100. Okay, example 4, check your understanding. So we go off and do this on your own, as usual, and then when you come back, we'll discuss it together. But it says, write an equation that describes the position and range of tower O. Okay, go ahead and stop the video, work on it, and come on back and we'll do it together. I'll wait for you. Okay, so now here's the solution. It says write the equation that describes the position and range of tower O. Well, where is tower O? It looks like tower O is centered right at the origin of the graph paper, right? At 0. 0, 0. Well, given that, and we know that the radius struck off from 0 to the circle is, these are 2 per, so it's 12, right? 4, 8, 12. So that's what the radius is on the circle. So we're going to write the equation. The equation is x minus what? The x value, 0 squared, plus y minus what? 0 squared. So now we have x minus 0 squared plus y minus 0 squared equals 12 squared. And then the actual equation is x squared plus y squared equals 144.